All right, this tutorial is on how to calculate the molar mass of a compound. So in class we talked about how to determine the mass of an element, and we do that by looking at the periodic table. Periodic tables typically have a key at the top that tells you where to find the average atomic mass, okay, which is the weighted average of all the isotopes of that element. So to start, let's look at sulfur hexafluoride, SF6. Okay. I have sulfur, which has a mass of 32 grams per mole. It's 32.086. If we round that to the nearest whole number, let's just simply call it 32. Okay, so 32 grams per mole. And fluorine, okay, has a molar mass of 18.998, so let's round that to 19. Now, I have one sulfur. There's nothing there, so I can assume that's 1. Fluorine has a subscript of 6. So what this means is we have 6 fluorine. So instead of writing 19 plus 19 plus 19 plus 19 and so on, let's call it 19 times 6. Okay, so I have 19 times 6 equals 114. Okay, 32 times 1 equals 32. And when you add those together, you get 146. Okay, so the molar mass of sulfur hexafluoride, SF6, is 146 grams per mole. Okay, so grams per mole is the unit on the periodic table that describes the mass. So if you add up grams per mole, your answer is grams per mole. Molar mass. Okay, so moles is a counting unit in chemistry, grams is mass, molar mass. Okay, in the next example, I have hydrogen and chlorine. The molar mass of hydrogen is 1.00794, which rounds to 1. The molar mass of chlorine is 35.45, so that rounds to 35. Since there are no subscripts here, we know that we have 1 hydrogen, 1 chlorine. So just for consistency, even though those are both 1s, I'm going to write how many times we multiply each of those. Okay, so 1 and 35, and then you add them together. Okay, so if you want the mass of hydrogen and chlorine together, you add up the mass plus the mass of chlorine. So the mass of hydrogen plus the mass of chlorine, and you get 36. So your answer is 36 grams per mole. Okay, in the next one, I have hydrogen and oxygen. Okay, the mass of hydrogen is 1. Mass of oxygen rounds to 16. Okay, so 15.9994 rounds to 16. Now the most common mistake is students forget that we have a subscript of 2 next to hydrogen. Okay, so the reason why we do this step is so that we remember to take into account the subscripts. So I have 2 hydrogen and 1 oxygen. Okay, so that's 2, 16, and now I add them together. The molar mass of water is 18 grams per mole. Okay, so I very commonly see students show that the mass of water as 17 grams per mole. Okay, they always forget that there's a subscript of 2. We have 2 hydrogen. Okay, so if we take a mass of 1 gram per mole, 1 gram per mole. Okay, we get 2, and then we add that to oxygen. Okay, so the next one is a little bit trickier. So sometimes we have parentheses. Okay, as we go and progress throughout the year, you will learn about ionic compounds and why we need parentheses on some of them. So I just want to point out we have 1 calcium and we have 2 hydroxide molecules. Okay, so you have calcium, you have OH, and you have OH. Okay, so you can think about it this way, where we have 2 OHs to deal with, or you can distribute the 2. So I have 2 oxygen and 2 hydrogen. Okay, 2 oxygen, 2 hydrogen. Okay, the parentheses means that 2 only applies to the things that are in the parentheses, which in this case it's OH, which we call hydroxide. So you've got 1 calcium, and the molar mass of calcium is 40. Okay, it rounds to 40. Okay, we have oxygen and hydrogen. Molar mass of oxygen is 16. Hydrogen is 1. Okay, we only have 1 calcium because there's no subscript there, but we have 2 oxygen and we have 2 hydrogen. Okay, so let's multiply that by 1. So we have 1 calcium, 2 oxygen, and 2 hydrogen. Okay, so again, this parentheses with the 2 on the outside means we have 2 of those, 2 OHs, so that's 2 hydrogen, 2 oxygen. Okay, 40 times 1 is 40, 16 times 2 is 32, 1 times 2 is 2. So when you add those up, you get 74. So your answer is 74 grams per mole. In the last example, I have another one with parentheses. Okay, NH4 is ammonium. So we have parentheses again, so that means that this 2 applies to this nitrogen and to this hydrogen. Okay, so when you have a subscript on the outside, you're going to multiply that by the subscript on the inside. Okay, both of these were 1. Okay, so we have NH4, NH4, and CO3. Okay, so nitrogen, okay, there was 1 to start. We're multiplying that by 2. Okay, so if you write it out, so I wrote out my 2 NH4s. Okay, so notice there's 2 nitrogen. Molar mass of nitrogen is 14, so we're going to multiply that by 2. For hydrogen, okay, we have 2 times 4 hydrogen. Okay, so when I wrote out my 2 NH4s, NH4 and NH4, because the subscript was 2, now if you look, 4 plus 4 is 8. Molar mass is 1 times 8 hydrogen. Okay, so you can either think about it as multiplying the subscripts, okay, or you can write it out. So 2 NH4, so NH4 and NH4, 4 plus 4 is 8, or 2 times 4 is 8, however you would like to look at it. Okay, and then I have carbon, which has molar mass of 12, and there is just 1 of them. Okay, so notice there's no subscript there, so it's just 1. Oxygen, molar mass is 16, and we have 3 of them according to this subscript. All right, so we get 28, 8, 12, and is that 48? Okay, and now we're going to add those together. 28 plus 8 plus 12 plus 48, and you get a molar mass of 96. So your answer is 96 grams per mole. Okay, so if you have a subscript that is just next to an element, that subscript only applies to that element. So this 3 means we have 3 oxygen. Okay, however, if you have a parentheses around some elements, that means that the subscript applies to everything in the parentheses and inside the parentheses only.